Hello and welcome to GCSE Chemical Changes with Mrs. Castanera. We're on Lesson 3, Reactivity of Metals. Today's keywords are displace, reactivity, electrons, energy levels, and electrostatic. So we're going to start with the knowledge check on page 21. So pause the video whilst you complete the 8 questions, please. So let's go through those questions. Question 1. Name the compound formed from magnesium and oxygen. That's magnesium oxide. Question 2. Explain why the answer to question 1 is oxidized. Well, oxygen is gained by magnesium, or alternately you can say that electrons are lost by magnesium. Question 3. Complete the list of metals in order of reactivity. The list of metals in order of reactivity is called the Reactivity Series. Question 4. The 2 non-metals in the list from question 3, the reactivity series, are carbon and hydrogen. You need both of them to get the mark. Question 5. The most reactive group 1 metal is potassium, at least of the ones we're looking at. Metals form positive ions. The group 1 metals listed in order from smallest to largest are lithium, sodium, potassium, or Li, Na, and K. And metal plus oxygen is a metal oxide. So give yourself a mark out of 8 for that, please. Okay, so today we are going to be able to recall and describe the reactions of various metals, and we're going to just construct a reactivity series from experimental evidence. So unfortunately we're not going to be able to do that part today because that is a practical based part of the lesson, but once we're back in the classroom we'll be able to do that. So the reactivity series of metals. When metals react with other substances, the metal atoms form positive ions. And if you recall, the reason for this is because they lose electrons. They lose their outer valence electrons. I'm going to make a note about this. Okay, so the reactivity of a metal is related to its tendency to form positive ions. Now, we've done this before. So it's more reactive when it's more likely to form a positive ion. And that, again, is related to its size. So metals can be arranged in order of their reactivity in the reactivity series. The metals potassium, sodium, lithium, calcium, magnesium, zinc, iron and copper can be put in order of their reactivity from their reactions with water and dilute acids. Okay, so the non-metals, hydrogen and carbon, are often included in the reactivity series. A more reactive metal can displace a less reactive metal from a compound. This is known as a displacement reaction. Okay, so I've just zoomed out so that you can see everything we've written in terms of notes here. Now, you'll remember that we've arranged the metals in order of their reactivity series, and that metals below hydrogen are found native, unreactive. If you look back at lesson 2 and 1, you'll see this. And that metals between hydrogen and carbon can be removed from their ore by heating them with carbon. And that metals that are more reactive than carbon need to be removed from their ore with much more energy, so using electricity, and that is called electrolysis. Now, unfortunately, we can't do the next activity because we would need to do this whilst observing the reactions of the different metals with water and acid. Now, what we can do is move on for now. So metals and metal atoms forming metal ions. So one way that metals react with other substances is by losing their valence electrons. So the more easily a metal can do this, the more reactive it is. And we talked about reactivity in terms of the size of the atom. So the further away the negatively charged electron is from the positive nucleus, the weaker the electrostatic force of attraction. And that is because positively charged nucleus, because it's got protons in it, is attracting the negatively charged electrons to it. The bigger the element, the more electrons it has in many outer shells, the further away the outer valence electron is from that positive nucleus. And so the weaker that electrostatic force between the positive and negative charges. So we can say that the relationship between distance and reactivity are inversely proportional. So distance and reactivity is an inversely proportional relationship, meaning that as distance increases, reactivity increases. So now that we've reviewed all that, which we did once already in lesson 2, we're going to be looking at drawing metal ions, which we haven't done yet. So we're going to complete the diagrams below by filling in the gaps, and the first one has been done for us. So this is sodium here, and sodium is a group 1 metal. It has 2 electrons in its inner shell and 1 electron in its outer shell. Its chemical symbol is Na, capital N, lowercase a. And so we've shown that it's got 2 electrons in its inner shell by writing 2, then a comma to show that the next shell only has 1. Now when sodium is turned into a sodium ion, okay, it loses that outer electron. So it turns into Na+, and so now it just has 2 electrons in its outer shell. It's got a full outer shell now. And to show that it's an ion, we put it in this big square bracket and we put a plus symbol outside. Now we can do the same with beryllium, and I'm going to show you beryllium now. So beryllium has 2 electrons in its outer shell. It's the next element along in the periodic table. It's a group 2 element. Its symbol is capital B, lowercase e, and it has 2 electrons in its inner shell and 2 electrons in its outer shell. Now here is a beryllium ion. We need to put on the crosses to show that it's got 2 electrons in what was once its inner shell but is now its outer complete shell. And it has 2 plus there because it's a positive ion because it's lost 2 electrons. So we put it in the square brackets like so, and we label it 2 plus. And then so the new electron configuration is just 2. So that is beryllium. Now what I want you to do is have a go at lithium and magnesium using the information that we've just done. Okay, so make sure that before you start that you've got everything written down from beryllium and sodium. Okay, and then have a go at lithium, magnesium, potassium and calcium. If you're not sure what to do, just do 1 or 2 at a time and check them 1 at a time as I go through them. I highly recommend that you do this activity in pencil so that if you make mistakes you can rub them out and start again and correct them more easily. So pause the video whilst you complete what you can. Okay, so let's go through that. Here we have lithium. So the symbol is capital L lowercase I, and it's 281 for the electron configuration because there's 2 in the inner shell, there is 8 in the next shell and 1 in the outer shell. And you'll notice there's an error with this one. These 2 electrons should not be here, they should be in this next shell out. So if you spotted that, well done. Then the lithium ion, so you should have labelled it lithium ion. And then it should have the 2 electrons in the inner shell and then 8 electrons in the outer shell. They don't have to be arranged like this, but this is the best way to arrange them. And it needs to have this big bracket around the outside with a plus. So I'm going to leave you 2 marks for this. 1 for the correct electron arrangement, so the correct crosses, and another one for drawing the brackets and putting a plus outside the bracket. And then here we just have 2 electrons in the inner shell and 8 in the next shell. So you've got 6 marks for lithium. So you can give yourself a mark out of 6 for lithium. So we're going to move on to magnesium. So here we have the magnesium ion. So if you've got a mark for that, it's capital M lowercase g. And then it's got 2 electrons in the inner shell, 8 electrons in the next shell. And again, the same mistake has been made here. And then 2 electrons in the outer shell. And when it becomes magnesium ion, it loses those 2 outer electrons to become Mg2+, with a configuration of 2 on the inner shell and then 8 on the next shell. And you get 1 mark for the correct arrangement of crosses here, and 1 mark for drawing the big bracket with 2+ on the outside. So for magnesium, it's also a mark out of 6. So we're going to move on to potassium. So the symbol is a capital K. This time they've done their cross diagram correct. Now here we've labelled it potassium ion, and it's K+, and it's 288 is the configuration. Now if you've got the crosses correct, so 2 in the inner circle, 8 in the next 2 circles, you can have a mark for that. And you can have another mark for drawing the big bracket and with a plus outside of it. So again, that one is out of 6. Moving on to the last one, calcium. So calcium is capital C lowercase a. Its configuration is 2-8-8-2. So it's got 2 in the inner shell, 8 electrons in the next shell, 8 in the shell after that, and 2 in its outer shell. It becomes a calcium ion, which is Ca2+. And so here we have the correct electron diagram for that. So it's identical to this one, minus the 2 outer electrons. So 2 in the inner circle, in the inner shell, then 8 and then 8. And then the next mark is for drawing the large brackets with 2+ outside of it. And again, this one is out of 6. So give yourself a mark out of 24 for this activity. And if you've got more than 12 out of 24, you've done very well because that was tricky. Before we move on, please make sure that you've correctly drawn all these diagrams by going back through the video and pausing where necessary. And again, you should have done it in pencil, so if you've made mistakes, it should be really easy to fix it. If not, then you might have to either redraw it out or print it out again. So moving on to page 23, task 2 here is about reactions of metals with waters and acids and our observations. So again, this is a practical activity that we can't do because we're not in the lab. Task 3 is similar. It's about observing the reactivity of these metals with water. Now this is a little easier to do. You should be able to complete this one by watching the following video, which is the reaction of metals with water. It's a Fuse School video on YouTube. If you've got a digital copy, you can click the link, or you can just type this into YouTube and find the correct answer. So fill those in and using the video to help you. So hopefully watching that video has given you a better understanding of the reactions of metals with water. We're moving on to the knowledge check activity now. There are 8 questions. I'd like you to pause the video while you answer them, please. Okay, so let's go through those questions. Question 1, name the type of ion formed by a metal atom. Well, they form positive ions. Question 2, explain why metals become ions. Well, they lose electrons. Or you might say that they lose valence electrons. Question 3, name the electrons in the highest energy level. Well, they are the valence electrons. Question 4, name the 2 nonmetals in the reactivity series. That's carbon and hydrogen. Question 5, name the most reactive metal in the reactivity series. Potassium. Question 6, state the charge of the nucleus of an atom. Positive. Question 7, name the force of attraction between the electrons and the nucleus. Electrostatic. Question 8, name the least reactive metal in the reactivity series. Platinum. Now give yourself a mark out of 8 for that. That was not that difficult. You should know all of these, so really you should have got 7 or 8 out of that one for everybody. So we're going to move on to the application of knowledge questions on page 24. Question 1, explain the trends of group 1 metals in terms of their reactivity and electronic structure. Question 2, predict the reaction of calcium and acid based on your knowledge of the electronic structure of calcium compared to magnesium. So which is basically, question 2 wants to know which one's going to react more violently and why. So pause the video while you answer those questions, please. Okay, so let's go through those. Question 1, explain the trends of the group 1 metals in terms of their reactivity and their electronic structure. So, the larger the atom, and they get bigger the atoms down the group, the further away the outer valence electrons from the nucleus, and the weaker the electrostatic force of attraction. In summary, the further down the group, the more reactive the metal. So the first mark is for stating the summary. Further down the group, the more reactive the metal. That's the main mark here. If you don't write anything else, you need to have this. Okay, so that's worth 1 mark, that statement. So there are some other marks to get here as well. Okay, so talking about larger atoms having valence electrons further away from the nucleus. So thinking about the valence electrons being further away from the nucleus, okay, that gets you a mark. And a third mark is we're talking about there being weaker electrostatic force. Okay, so you have to talk about the electrostatic force being weaker, okay, related to them being further away. So there are 3 marks there for that question. Question 2, Predict the reaction of calcium and acid based on your knowledge of the electron structure of calcium compared to magnesium. Well, first of all, you need to know that a metal and an acid turns into a salt plus hydrogen. If you've written that, you can have a mark. Now, I suspect most of you have forgotten this. This is something from an old topic. So I want you to write that down if you have not got that written down, okay? Because that's really important to know. Then you need to explain that calcium is more reactive than magnesium. There's a mark for saying that. And that then to explain that because it's more reactive, it will have a more vigorous, more violent, more energetic, or just generally more of a reaction. So there are 3 marks for this one as well. So 1, 2, 3. So that's a total mark out of 6 for this. Now, again, this was quite tricky. It required you to take a lot of information that you knew and write it down. Question 1 was especially lengthy. So if you got 3 or more out of this, that's still a good mark. If you're a higher tier student, I would hope you get 4, maybe 5 out of this one. Okay, so make sure that you have written down anything you did not get the first time. Feel free to use the notes page to do that. So moving on. Checkpoint question. Explain why you do not need to react gold with carbon to obtain pure gold, and that is worth 2 marks. So pause the video whilst you answer this question. Okay, let's go through that question. First of all, why don't you need to react gold with carbon? Well, gold is unreactive. It doesn't react with hydrogen, doesn't react with carbon. It doesn't need to be extracted from its ore. Gold is found native, or it's already found as pure gold in the earth. So there are 2 marks here. So give yourself a mark out of 2. Okay, I would expect that most of you have got at least 1, probably 2 on that question. Make sure you've got everything written down there if you didn't get it first time. So we're going to move on to the keywords, which are displace, energels, and electrostatic. Make sure you learn those keywords. You should know them. You don't need to know them exactly word for word, but you do need to be able to give a good, very close definition to what's written here. And that is the end of our lesson. Thank you very much. If you have any questions, please feel free to ask your teacher, or myself will be very happy to help you.